What is going on, Internet? Lou here, and today I am bringing you the long-awaited, greatly overdue Android Kernel tutorial. Now, for those of you that have been patiently waiting for a very long time for me to put this tutorial together, my apologies. I promised this video to you guys a long time ago, and but I'm just getting to it now. So, anyway, better late than never, right? And for those of you who are new to the channel, again, welcome. Hopefully you like my content. Not only do I do a lot of work in Linux, but I also do a lot of work in Android as well. I've got various ROM projects for both the HTC Incredible and the HTC Thunderbolt, and I will be picking up a new Android device, hopefully not too long into the future, and I will be releasing videos for that as well. So if you're an Android user, stay tuned. I'll be doing a lot of videos for that, and if you're a Linux user, stay tuned because I love Linux too. Continue to produce a lot of Linux content. Now, a couple of things to get out of the way in the onset of the video. My host system that I'm going to be compiling this kernel on today is Fedora 16. Now, if you're not using Fedora, no worries. What I'm going to be doing, as per usual, in the blog post below, you will see a step-by-step written instructions to follow along with this video. I'll also include the packages you are going to need to install if you're on Fedora, and I'll include the packages you're going to need to install if you're on Debian or Ubuntu or any derivative thereof. So I know there's a lot of other distributions out there, but it's really hard for me to go and hunt down all the packages for all the different distros. So Google's your friend if you're not using Fedora, Debian, or Ubuntu. Other than that, all of these steps are going to be identical, so no worries as far as the commands are concerned. And when we hit the terminal, they're all going to be identical. Now, I'm using an HTC Thunderbolt for this demonstration. If you have a different phone, that's okay. The process is going to be the same. Now, the only thing that may or may not differ is the tool we're going to use today to install this particular kernel. Now, I have to give credit to the developer, which is Kush. He's also the developer of ROM Manager. So if you're an Android user, you most likely, if you have a rooted device, have ROM Manager installed on your phone. Well, the same developer that put ROM Manager together is going to be showcasing his tool called AnyKernel Updater in the video we're going to be doing today. So Kush put this tool together, and another kernel developer by the name of Ziggy actually modified this to work on the Thunderbolt because certain devices this particular method was not working. So he tweaked it and got it to work. So many thanks to Ziggy for that. And so let's get to it. Now, if you need to install any of the packages, please see the blog post. Get those packages installed. It should only take a couple of minutes to get that done. After those packages are installed, we're going to need to get the toolchain to be able to compile this particular kernel. I'm going to show you where to get that. So if we hop over to Google here and type in Android NDK, the first hit here on Google, go to that link. Should be developer.android.com/ndk/ndk. We're going to see right here where it says Linux 32/64-bit Android NDK revision 7. This is where you would normally get the NDK. Now, there is a caveat to this. This particular toolchain that's included in the NDK here, it has been breaking the Wi-Fi module for me every time I try to compile a kernel. Okay, now there's different toolchains you can use out there. There's CodeSource's toolchain, which actually was giving me some issues as well. Luckily, again, thanks to Ziggy, actually, I was able to get a hold of an older version of the Android NDK. So I will put a link to be able to download an older version of the NDK in that blog post so you can get your hands on that. I'll also be including a link to the modified AnyKernel updater to install this kernel if you're using an HTC Thunderbolt, and this will probably work on another device, although it is untested, so use at your own risk. So all you would do here is just click on the link and download the Android NDK. Now, for to save time, I've actually already done that. Next thing we're going to want to do is we're going to want to get the kernel source code for your particular device. Now, if you're using an HTC device, they have a really nice website that they have set up. It is htc.dev.com. You're going to see the link right here where it says kernel source code. Just click on that and then click See Downloads. And here is all of their Android devices. And because of the GPL licensing, they have to release the source code to their kernel. Now, they do not release their source code to their proprietary versions of Android, meaning if they're using if you're using a Sense device, they do not release the source code to Sense. However, if you are an Android user that is using an AOSP ROM or an Android open source project ROM, meaning it's completely unmodified, and a completely unmodified Android experience, sometimes referred to as vanilla, a vanilla ROM or a vanilla Android device. The source code to that is available on Android's Git repository, which you'd be able to download and modify at your leisure. So, download the source code for your particular device. Now, if you're not using an HTC device, all of the other major OEMs, I know Motorola, Sony, they all make their source code available as well. Hop on Google, find the website that you need to go to, download your source code. Okay, again, for the sake of saving some time, I've gone ahead and downloaded that already. Now, I'm going to show you guys what I have downloaded here. So what you should have is the AnyKernel updater. You should have the source code for your particular device, and you should have the Android NDK. Okay, if you have those things right there, we're in business. That's all you're going to need. Now I'm going to open up a terminal here, and just to kind of keep things neat, I created a directory here in my home folder called Android Kernel, Android-Kernel. You don't have to do that. I tend to want to kind of keep things organized, so I went ahead and created that directory. Now, before we actually get into really the nuts and bolts here, why would you want to create your own Android kernel? Well, with the source code available for the kernel, you're allowed to modify it, and you're allowed to do things to the kernel, much like you can do to the Linux desktop kernel. You can apply any type of patches you want. If you want to run a BFS CPU scheduler or a BFQ IO scheduler, there's all sorts of performance patches to do things such as increase the SD card read-write speed, all sorts of different things. If you want to overclock or underclock your device, you can also do that. If you want to run a more conservative, say, governor, pun intended, you can say you want a lot of real long battery life on your device. And you can change the actual default governor on your device to run to say, a conservative or maybe an interactive or power save governor if you want battery life. So, there's a whole host of reasons to compile your own kernel, aside from it's the geeky thing to do and it's a lot of fun. So, those are some of the reasons why you may want to compile your own kernel. Now, as far as overclocking and underclocking, here's my opinion on that. Quite frankly, I'm not a huge fan of overclocking phones. Really, in my opinion, you're not doing things that are so CPU intensive that you really need to overclock your phone. What really ends up happening is your battery life really pays the price for it. Now, underclocking is a different story. You may want to underclock your phone to, again, conserve battery power. That's one thing, but the overclocking, honestly, until these phones can do things more like, say, a desktop or even a laptop would be able to do that's really CPU intensive, I can't see a reason why you would want to overclock your phone. Just for the simple applications that we run, we're not doing anything too heavy. And, again, when you start overclocking, different devices will handle overclocking differently. I know when I was running an Incredible, my brother's got one, I have one. My device would be able to handle an overclock. His device would not be able to go above the standard 1 gigahertz processor speed. So anything else than that, and his phone would just freeze up, and we'd have to do a battery pull and reboot the phone. So, each phone's got to handle an overclock differently. If you go with the standard CPU frequency setting, you're really not going to have to worry. Okay, so that's my thoughts on overclocking. Now let's get everything all squared away. So what I want to do is I'm going to move these a couple of these packages here. We're going to move my source code into my Android kernel directory. All right, we're also going to move the AnyKernel updater into my Android kernel directory. Okay, and next we're going to basically untar this particular Android NDK. So we're going to do that by executing tar xvf and then the name of the particular tar file, and then hit enter. And as you see, it's untarring all the contents of that particular file. This is the revision 5C, by the way, NDK that we're using here. The current version is revision 7. Alright, so that's all done. What I'm going to do is rename this to NDK, just for ease of make things a little bit easier. Alright, now, what I want to do is I need to point the tools, the compilation tools here in the NDK to my kernel source. Actually, you know what? Let's untar the kernel source first. Get that going. Alright, so let's cd into Android Kernel, and let's do another tar xvf and my kernel source. Very good. Okay, now I'm going to symbolically link my kernel source with a directory we're going to create called Linux. Okay, very good. So this is all set. Next thing I want to do is point my NDK that we have here, the tools included within my NDK. Now those tools are going to be found here in Toolchains, the ARM EABI 4.4.0, pre-built Linux-x86, and bin. These are all the tools we're going to be using today here to compile this kernel. All right, we want to point these tools to where our kernel source is. Okay, so what we're going to do now is we're going to cd into. Actually, you know what? We're going to cd into Linux. All right. Next, if you go to my blog post, you can just copy and paste this particular line of code that I have here. Now, one thing to keep in mind, when you paste this in, you're going to notice that where it says export cross compile equals home Rizzo NDK, this part here, home Rizzo, this is the path to where your NDK is. Mine's in my home folder, so it's home / what's my username, which would be Rizzo, and then it's located in the NDK folder, and then here is the rest of the path. Okay, so basically just change the beginning of this path to wherever yours is, and you can keep anywhere from where it says Toolchain all the way to the end the same. Okay, once we do that, we're just going to hit enter. Perfect. Now we have pointed those tools to where our kernel source is. Now, just like I've done in all my Linux kernel videos, what we want to do here is we want to make sure that we prepare our kernel source for configuration and compilation. The way that we're going to do that is by executing the command make clean and make Mr. Proper. Oh, actually, hold on here. You know what? One second. I think I know what I did wrong. See? Even people who've done this a while get these things wrong. Alright. Oh, I think I pointed it to the wrong one here. Hold on. Hold on. Alright, I'm going to have to make a correction in the blog post because I've pointed you guys to the wrong. Whoop. It's not 4.4.0, it's actually 4.4.3. Let's fix that. Let's run the new command, make clean and make make Mr. Proper. Bingo. All right. So, even someone who's done this a ton of times can make a mistake here. Above, right here, where I pointed it to the tools 4.4.0, it was the wrong directory. It should have actually been 4.4.3. So, keep that in mind. Okay. Now we've run a make clean and make Mr. Proper. what we want to do now is if you've watched any of my other Linux kernel videos, you want to start with a base. You want to start with a foundation. You want to start with a config, okay? So what you're going to do is you could do a couple of things. Now, here in the tutorial, I showed you a way to use the Android SDK and pull the current config from your device. Excuse me here, I need a little iced tea break. You can do this. No big deal. If you have the Android SDK installed and you know how to use it, great. You can do this. Or I can show you a different way. If you go into your source directory, so we've got my source right here, and you go into Arch, ARM, and we're going to go into boot. I'm sorry, no. Arch, ARM, and configs. Here's all the configs contained within my source directory. Okay, now remember this is the source code for my particular device. Now what do I have? I've got a HTC Thunderbolt. So right here is the config I want. I want the mecha-lte_def config, or the default config. All right. So what I'm going to do is I'm going to run a command, make, and I'm going to say mecha-lte_def config. It's going to run a script, and then boom, it's going to write the default configuration. Okay, that's important. We need to write a config. Now, I want to configure this even more. So we're going to do a make menu config. Now, this is going to open a graphical user interface, very similar to what we were used to in my Linux desktop kernels, to basically configure this even more. So let's see here. General setup. You know what? Let me turn this off. All right. And just like on the Linux desktop, if you want to include something in the kernel, you're going to do that by hitting the Y key on your keyboard. That's going to indicate yes to include it. You'll see an asterisk here. That means it's going to build it into your kernel. If you want to take something out, what you're going to do is you're going to hit the N key on your keyboard. That means do not include it, and it's the parentheses will be, or these brackets here will be empty. And if you want to build something into the kernel, but you want to do it as a module, you're just going to hit the M key on your keyboard, and that will build it as a module. All right, so let's see here. And again, if you're unsure of what something is, you always have a help feature, so you can toggle over here to where it says help, hit enter. This particular option, the config swap, this option allows you to choose whether you want to have support for so-called swap devices or swap files in your kernel that are used to provide more virtual memory than actual RAM present in your computer. If unsure here, say yes. Now, what you can always do is you could partition your SD card to have a swap partition, and if you did that and included this particular feature, you can actually use a swap file just like you would on a Linux desktop. Okay, so I'm going to include that. Let's see here. Okay, we are optimizing for size. Again, if you've watched my other videos, a smaller kernel is a faster kernel. That's a good thing. Alright, so let's see here. I/O scheduler. This is set up for deadline. I want to change that. I want the CFQ I/O scheduler. Alright, so I'm going to change that. Alright, system type. Here we go. Now, again, be careful what you enable or disable. You could make your system unusable if you disable something that you know that's actually system critical. So be very careful in here. But over here, this HTC performance lock, if you want to overclock or underclock your device, basically change the governor that you want to use at will, you need to disable this. Okay, so we're going to hit no here. So we disable the HTC performance lock. See. We're not going to get too crazy on this. We're going to keep it a fairly standard kernel. We're not going to get too flashy. Let's see. All right, that's all we're going to do there. Kernel features. All right, this is already set up by default for a preemptible kernel for low latency. That's good. Right down here, you can see where it says use the ARM EABI to compile the kernel. That's the tools that we're using in our toolchain for this compilation. Let's see. Boot options, we're going to keep the same. CPU power management. Here's where you can change your default governor. By default, this is set up for on-demand. But if you wanted to change it, boom, you can change it to any one of these governors that you'd like. And if you want to include them in your kernel, again, you can just hit yes. On-demand is fine for me. And I know that's the one I'm always going to use, so I'm not going to bother including anything else in here. Let's see here. CPU idle PM support. If you go to your help file, again, here's another example. It's a generic framework for supporting software-controlled idle processor power management. It includes modular cross-platform governors that can be swapped during runtime. If you're using an ACPI-enabled platform, you should say yes here. Again, we can leave this as not being included in our kernel, but that's just another demonstration of the help file. So if you're unsure, use help. It comes in handy. All right, power management options. Let's see here, suspend to RAM. That's all good. All right, advanced power management emulation. I'm actually going to include that. Okay, that's good. Let's enter. Get out of here. Kernel hacking, kernel debugging. We're gonna take that out just for a little bit of increase in performance. We're gonna take that out, and that's it. Again, this is a very basic config here for our device, but we've disabled the HTC performance lock, so now we can overclock or underclock our kernel. We changed the I/O scheduler from deadline to CFQ, and we left the CPU governor set to on demand. If you're unfamiliar with on demand, very brief description. Basically what it'll do is it's going to scale your frequency for your CPU from, say, a very low CPU frequency setting if the system has no load on it. For instance, if your screen is off, nothing's really going on. And then, when you turn your screen on, and all of a sudden there's going to be load on the system, it'll scale it up to the highest that it can go. Okay, so it's either going to be set to a very low setting or a very high setting. It doesn't mess with anything in between, and that's perfectly fine for me. Okay, so what I'm going to do now is I'm going to go to exit. Do you wish to save your new kernel configuration? Yes. Okay, now, what we're going to do is we are going to actually compile the kernel. Now, I'm going to stop it here because it tends to, the screencasting tends to get messed up a little bit during the compilation process. But what I'm going to do is I'm going to go ahead and show you the commands that are necessary to compile the kernel at this point. And then when I come back in part 2, we're going to learn how to basically find all the pieces of the kernel after it's done and load it into the AnyKernel tool. And then we're going to actually flash it on the device, and I'm going to show you what that looks like, okay? So if you want to compile the kernel, what you're going to do is you're going to run the command make. And again, I referenced the J tag in my other kernel videos, but if you're on a multi-core processor, this actually optimizes the build to basically hit on all your cores. I have a quad-core machine, so the general rule of thumb here is you would type make-j, and then the number you would include would be the number of cores you have plus 1. So if I have 4 cores, add 1 to that, it'd be a make-j5. And next we would do arch, all uppercase, then you would do equals arm. Okay? That's it. Now, actually, you know what? Before we do that, let's give this kernel a specific name, okay? You want to have your kernel to have a specific name on it, and that's fine. We can do that. So what we're going to do is we're going to come over here to our make file, go into your kernel source directory, open up your make file, and right down here, it's going to be the 4th line down. you're going to see extra version equals. It should say 0.10. We're going to do dash. Hey, it's Lou. I'm going to call this mecha dash version 1. And that's it. Okay. 64 characters, I believe, is the longest you can go. You can't use any capital letters. You can't use any special characters. You can't leave spaces between anything. Okay. Couple of things to take note of as far as the name you give your kernel. Okay. We're gonna hit save. This will give our kernel a special name, and I'll show you where to find that name on the device afterward. So again, I am going to pause this video here. When we come back in part 2, I'm going to show you guys the final product, where to find all the pieces, how to put it into the AnyKernel updater tool. We're going to flash it to our device, and then I'm going to show you what it looks like after that. We'll see you in part 2.